Welcome back once again. In the previous videos, we solved questions on inverse function and composite function. So today we'll be solving questions on polynomial function. My name remains Akonji Korede, an advanced function maths tutor. So let's go. Number 3. Now, given the polynomial function p of x, that is 4x cubed minus 2x squared plus 7x minus 3, find the critical point of p of x. So what is critical point? So let's quickly rewrite the function 4x cubed minus 2x squared. Okay, so a critical point is a point where the differentiation or the gradient is 0. So in order to get that, okay, we need to find the derivative of the polynomial. So now number 3. So we have p of x to be 4x cubed minus 2x squared, okay, plus 7x minus 3. I think let us verify. 4x cubed minus 2x squared plus 7x minus 3. So that is the polynomial function. So we need to find the first derivative, p prime. So p prime, I mean the law of derivative or differentiation is just to multiply the power with the coefficient and we minus the power by 1. So we have 12x squared minus 4x plus 7. So that is p prime. So critical point is the point, at times we call the critical point turning point as well. So the point where the differentiation is equal to 0. So what we need to do is that we equate this difference derivative, which is 12x squared minus 4x plus 7 equals to 0. So this should be solved. This is a quadratic equation, but we need to pay attention to that equation because not every equation can be solvable. A quadratic equation solvable. So we need to use the discriminant principle to test if this equation is solvable. So now the discriminant here is the formula of discriminant is b squared minus 4ac. B squared minus 4ac. So having known that b squared minus 4ac, so if d, which is the discriminant, is positive, then that is b squared minus 4ac is greater than 0. So in this case, we have two distinct solutions. Another one, d can be 0. In this case, b squared minus 4ac equals to 0. So in this case, we always have only one root. So only one root. So we have two, for this case, two distinct roots. Okay. For this case, one root, okay, and that is equal roots. And for the third case now, D can be negative. So that's just digression for this solution. If D is negative, so it's telling us that B squared minus 4AC, okay, is less than 0. So in this case, we always have imaginary. So no solution. I say no solution for this case because we are not treating complex number. So no solution. Okay. Or it has imaginary and real solution. But let us go back to our questions. This is just to re-explain the concept about discriminant rather. So now, you can see that in our equation for differentiation, so our B squared minus 4AC, let us test it. B squared here is 4 squared minus 4AC 12, 7. Okay, so we have 16 minus, I think that is 336. Okay, so we end up getting minus 320. So since this the discriminant is negative, so this discriminant is negative, then negative, it has no solution. So and if it doesn't have solution like that, it implies that there is no critical point. So because there's no way we can get a value for that. So though there is a concept of complex number, which is another concept, but we have to get a real solution since it doesn't have the real solution without the imaginary solution. So the critical point, okay, critical point does not exist. DNA. So that is the first spot. So critical point does not exist here because we don't have uh, the solution to the quadratic equation. So the second question here says that determine the intervals where P is increasing and what decreasing. So again, when we want to know if the polynomial is increasing and decreasing, okay, we still need to use the concept of critical points. So definitely B, since there's no critical point, because the critical point at this time does not exist. So definitely the interval does not exist. The increasing or decreasing interval does not exist. The increasing, okay, or decreasing interval okay, does not exist as well. And the third question here, we are asked to um, identify the local maximum and local minimum. So there's no way we can identify that because we have two types of critical points. The critical point can be local minima and local maxima. So since we don't have what to test, so using first derivative test, so definitely the local maxima and local minima does not exist as well. Does not exist. So we, if there's critical points, definitely we can know the increasing and decreasing of a function, and through that we know if we have local minima or local maxima. So it shows that the equation, this graph of this function, is there's a point of inflection at the origin. So that's what it's showing. So it has origin. So, but that is that, by the way. So because, as I said, this is just to consolidate. So we are not opening. I'm not opening the full content of the topic. So that is why we can say that the local minima and local maximum does not exist as well. Thank you. In next video, I will be solving question number 5. So on another topic. So see you then. Thank you very much. Have a great day. Bye.